Good afternoon from Portland. Hello, my name is Helen Leigh, and I am your host today of the Teardown sessions. In a moment, we'll be speaking with Zoltan from Spacewalker LNA, and we're going to be talking all about CubeSats and ground stations and RF and all sorts of fun things. But before we do that, I would like to tell you about what's going on at Crowd Supply at the moment. We've got a pretty... I'm starting off with a big congratulations to Tangara, Jacqueline's awesome open source iPod with lots of really awesome functionality. That just closed yesterday with a massive 273,000 raised there. Lots of excitement in the community about this particular device. So I just wanted to say congratulations to Jacqueline. You did a great job. Crowdfunding now, we've got a couple of things that have just launched. We've got this cute little RISC-V dev board. Love seeing a lot more RISC-V make its way into products and dev boards nowadays. It's been fun to watch that develop. But we've got this ESP32 little bug. So if you're interested in RISC-V development, RISC-V and ESP32 development, it's really worth taking a look at that. Lots of interconnectability with Home Assistant as well, if you're one of the Home Assistant users. What else have we got? Oh, we got this little analyzer. Again, another ESP32. You can't go wrong with ESP32 with a nice little USB debugger. So it's kind of a thin little project there. I wanted to highlight a few things that are coming soon. Leon and Navi, who is a regular here on this stream and a regular creator of Crowd Supply, is releasing his most recent device that he developed for a bunch of gamers. And it's a, you can see what it is. It's a nunchuck controller, right? Yeah, you get it. Another thing coming soon, which is really fun, this is getting real popular at the moment, is Poly Keyboard, which has got each of these keys are addressable and programmable, so you can change them to any character set you want. Tiny little screens in the keycaps there. It's real fun, and people are going wild over that. So that's kind of fun. What else? Noah, our regular creator, Lime, and many of you will already know about the Lime technologies, but they've got a new project coming soon, which is a radio front-end carrier board for the popular Lime SDR XTRX and the Raspberry Pi CM4. So that's barreling along towards the campaign. So if you're interested in that kind of thing, I would definitely check that out when it comes out. Very powerful thing. Oh, yes, I also wanted to tell you about Teardown. So as most of you will probably already know, we run an annual conference all about hardware and open source and like hacking and materials, et cetera, et cetera. We run that every year. And this year it's 21st through 23rd of June. The CFP is open right now. We have a hacker art exhibit, we have project tables, we have like a big maker space, we have talks and workshops. So if you're interested in contributing in any way, please do submit your proposals now. I'm starting to go through them this week, in fact. So if you have submitted something, you expect something in your inbox in the next week or so. So that's happening, and tickets are on sale as well as the CFP is being opened. So take a look at that if you are interested. Okay, so before I bring on my guest, I wanted to give a big shout out to the sponsor of today's stream, Qorvo. And they ran something called the Qorvo RF Accelerator, which our guest today is part of. Essentially, it's a program that Qorvo run with us to both help out and also subsidize the crowdfunding campaigns of projects that are using Qorvo components, which you can see a few of here. Very popular one. We gave the Caribou light away on the last stream, I believe. David Groom won that. Yeah. So you can see some of these things, and right down the bottom here, this is what we're going to be talking about today: the Spacewalker LNA. It's very fun. All right, let's go over to this. This is the pre-launch page for Spacewalker LNA. Let's have a little look at this. And I'm not going to tell you anything about this because we've got somebody on the team here to tell us about this. Let me just remove this and bring on Zoltan. Hello, Zoltan. Thank you so much for joining us on today's stream. I'm very excited to learn more about your ground station happenings. So do you want to introduce yourself for the lovely people at home? And tell us a little bit about what you do.
Yeah, I'm Zoltan Doczi from Budapest, Hungary, Europe, and I have graduated from the Tech University here in Budapest. in 2007, and since that time I've been working in the industry in the semiconductor and mixed signal digital business, dealing with small radios like system on chip radios and such. And after some years, I just started the consulting and freelancing business. And also, one thing didn't change, that I still keep relationship with my hobby, which is the ham radio. And yeah, fascinating stuff around radio frequency stuff. And
yeah, which I'm hoping to learn a lot about during this conversation. Very exciting. And tell me about your connection with Decent Labs. What is Decent Labs exactly?
Decent Labs is situated in Budapest. Is one of my friend Viktor Szatmári is running it. Actually, they strongly believe in the decentralized market and decentralized technology. So they are dealing with this cryptocurrency stuff, and like distributed system like the LoRa radio systems, and yeah, so such things which showing the sign of innovation into the new technology systems around the decentralized networks generally.
And what's the Spacewalker LNA? Because this is a very specific object. I'd be curious to hear about it and how this came about.
Yeah, and the connection with this LNA is the space. So we both agreed with Victor on that it's going to explode in an exponential way.
You mean
space market? I mean,
yeah.
Possibly due to SpaceX, which is pushing down the launch price, and luckily due to that, more and more universities can launch their CubeSats and PocketSats.
For those people who aren't familiar with the term CubeSats, can you give a really brief introduction to what a CubeSat is?
The CubeSat is a small, like 1 unit or 2 units, 3 unit satellites. Yeah, it's like the one. Yeah, it's a like 10 by 10 centimeters, 10 by 10 by 10 centimeter cube, which is quite popular right now in the university space, university and educational programs, because it's really simple. The price of the launch is influenced by the weight of your satellite. So less weight, less cost.
Oh, I see. Well, that makes sense.
Sorry?
That makes sense, of course. Yes.
Yes, of course. And even these small satellites can cost you like $10,000s to launch. So
wow.
Still, but it's cheaper than like 10 years ago.
Yeah, of course, like massively cheaper.
And there are a lot of smart integrators in the business, like there is a space in the head of the rocket, or the nose of the rocket.
Yeah.
And there are like a huge satellite, like a 500 kilogram satellite there, but that's actually it's a smart payload with a lot of smaller bins where you can fill up your small CubeSats, and that company is selling the space for you like a middleman. But they do it in a Alba Orbital, for example. But they do a little really nice job in that way, that they arranging the logistics and making the efficiency.
It's much more accessible now than even a few years ago. Absolutely. I'm seeing a lot of universities doing these CubeSat projects. And it's very exciting for a student as well to actually get to work on something that's going to go into space, It's like applied knowledge. All right. Thank you for the explanation of CubeSats. Let's continue with the story of how this came about then. So you're...
Yeah. And so you're launching your satellite, you get the money for it, and you're happy, and it's up there. And now the next big thing: how do you receive your packets? So you can have a ham radio community around your satellite if it's tempting enough, or have something to do with the ham radio, or you can rent a cloud-based service, because there's already out there something like that. Or you can rely on the SatNox, or you can build your own radio station, which is really, really expensive if you consider everything. You most likely want to have a positioned antenna with a rotator, a 2-axis rotator, to keep your satellite in the beam. And those, most likely in the UHF band, that will be like 1 or 2 big Yagi antennas. So it's everything expensive, and you have to put it into the roof of your university, for example. Then you have to care with the lightning safety.
Of course,
So
yes.
things things slowly but surely adding up, and you don't have a LNA at that point. And
Yeah.
not those.
LNA being low noise amplifier.
Yeah, it's a low noise amplifier.
Yeah.
Yes.
Cool.
because the software defined radio, what probably most of the guys out there using, like the RTL SDR in the metal case, aluminum case, it's a really nice device, but what is good in it, the flexibility, it is the bad thing in it. So there is no filtering. It's receiving everything what it gets in its wide bandwidth. The noise feature is also not really good. So it's
and is that more of a problem in the city?
Yes, that's true. But in itself, the SDR is not. It's for some satellites which is strong enough. It can be useful in itself. But the noise feature in these dongles are designed for the DVB-T reception.
Interesting. Yeah, so ground stations. When I think of the ground stations that I thought of growing up, they were all giant and fixed, right? And nowadays, like, you've got, the SatNogs. By the way, big shout out to SatNogs, who just reached 9 million observations. So that's really, congratulations. That's a big milestone for them. Nice. Yeah, I know. Good for you, SatNogs. They're from Greece, aren't they? I think.
Yes.
Yeah. Yes. Cool. Anyway, big up SatNogs. But they used to be like much larger and fixed. But as, of course, technology has moved along, I've been seeing a lot more, like handheld receivers or small receivers that you might put in your backyard. I wonder if you might tell me a little bit about what kind of receivers one might have at home, not necessarily in a giant institution. Hang on, wait. Let me put you in solo so you can people can see it. Tell me what we're looking at here.
So this is the so-called Yagi Uda antenna, which is invented in Japan by Yagi and Uda engineers, like, I don't know, 200 years ago or around 50 years ago. This particular this one is, maybe this is for Wi-Fi. I'm not sure. It was just here in the desk. And for the UHF satellite communication, you will need a little bit bigger, which is 70 centimeter, and the dipole element here is what the most important thing for this. And you have to scale it for your frequency, obviously, with all the parasitic elements. This is the reflector back here, so it's helping you to orient the signal coming from that direction. And these are the parasitic radiator elements. And as a rule of thumb, the more elements you have here, the higher gain the antenna will have. And this is what it means, that it's just shrinking down the beam width of the antenna. So
that's the beam width. You mean?
Like an optical lens, but this works in the radio frequency domain.
Because I know you've got, when we're talking about this this kind of thing, we've got the different bands, right, which is referring to the frequency. Am I correct there?
Yes.
And then the beam types as well. That's what. Can you tell me a little bit more about that? Is it the beam type that's coming from the satellite, or is it the beam type that is, what does that mean?
Regarding the electromagnetic wave, what you want to receive, you can have different properties. Like the most important is the frequency. So let's the current example of what we are talking about now, the Spacewalker, it's working in the 434 megahertz band, which is the 70 centimeter band.
Yeah.
Which is the length of that
right
frequency.
There in the title.
Yes.
Yeah, 433. And why 434? What's optimal about that? What are you trying to achieve? with that
That's
particular
that's
frequency.
that's the 70 centimeter ham band, ham radio band, one of the maybe the second more popular. And also there is this band is allocated for these kind of low Earth orbit cube satellites.
Now, I was going to
Most
ask
of the
about
time.
those. So I know that there's like GEOs and MEOs and LEOs and all of that kind of stuff. Does that affect what you can pick up? Can you normally just pick up one of those things, or is it irrelevant to what you can receive?
You mean the satellite
Different
orbit
positionings? Yeah. The different
relation to the frequency? It's
I
a
mean,
good question. What is the coordination amongst that? But I know that usually the LEO satellites using this UHF.
interesting.
But for example, the GEO
Yeah.
broadcast satellites are using the 10 giga, the Ku band, like the 10 gigahertz.
Yeah.
So there obviously there is some planning and mapping to avoid interference between them.
Yeah. Super interesting. Thank you. I've got a couple of questions here while from the audience. First of all, let's say hello. So Drew's here in Portland. Thanks for joining us, Drew. Hello. And then Francisco, hi, nice to see you again. And we've got
guys.
Salman from India. Nice to see you again. See you on the stream.
Hello, guys.
Yeah, and Leon and Abby, who we gave the shout out to the Nunchuk, his upcoming Wii Nunchucks project. He's in there as well. Hi, nice to see you, Leon. From Bulgaria. A couple of questions here. First one from Salman. He says, what kind of rockets are used to launch? And do you use any launch services? Now, we did touch on that earlier, but I'm also curious because there's a number of different launch services now, right? There's not just SpaceX. There are...
Yeah, it's a good question. Which do you want to use? If you go to the Alba Orbital, which is a integration, how can I say, launch integration provider, maybe. Sorry if I'm not using the good term here. I think they just go where is the more efficient price, and you don't have to care about it. You just
interesting, so much easier.
It is just you're just ordering a taxi, and you just go step outside your house, and you're just sitting into the car, and you don't care about it. If you want to go by yourself, of course you can have you can get your ticket to ride, and more
that's so interesting
providers there. Space is one of the most cheapest nowadays.
So it's interesting that people are using middleman, generally speaking, in order to organize it.
But they are good guys, so they are just helping. The sharing. It's like a pool, sharing the cost of the. It's like a satellite Airbnb, or how I can say.
That's so interesting. That's so interesting. I got a comment again as well from Salman saying antennas are like a torch, lower dBi to higher is like a normal torch to laser. Higher dBi is kind laser. It can reach a longer range, but super focused. And at the same time, lower dBi is shorter range, but scattered. All right. Thank you so much for that explanation. That was really.
Or just a simple example. If everyone can imagine if you have you out in a summer day and you have a glass magnifier, and you just you can light a little fire on a wood, like what you played with in your childhood probably. It's the same. It's just you're focusing the energy in a little narrow band. That's exactly what the same happens in the antenna field, but we cannot see it. And and also for poor man's satellite antenna, what I was doing also, and many out there, if you have this kind of long and high gain Yagi, then you will need to have the rotator. But that's expensive, quite expensive, like I don't know, $2,000. But if you don't want to rotate your antenna, then what you can do is to use like a 3-element or 4-element Yagi, whereas the beam width is wider, and you will spot the satellite even if your antenna is in a fixed position.
Interesting.
Or there are out there many other antenna types which can be used for a stationary use without a rotator.
And what kind of data are you getting from that? Like what kind of classes of information? Is it like weather data, or is it that kind of, but also like how are you receiving it in terms of like how do you get it off of the antenna, right? How do you put? Is it connected to your computer? Like, what's the process there for getting?
Okay, so just go back to here. So you have your antenna, you have an LNA,
Yeah.
and you have the next chain is the SDR
Mm-hmm.
in the connection, and then your PC.
Yes.
So, and what you get on your computer is usually the IQ stream going down in the USB connection.
Okay.
So at one point you will have the baseband of that signal, which can be like 20, 50 kilohertz wide. And here you will have some kind of decoder program. Those satellites usually using FSK, GFSK, GMSK, OOK, CV, like the Morse code. Some using that format.
Oh, really? Fascinating.
Some using FM, but it's quite rare.
Interesting.
I'm talking about the CubeSats.
Yes.
Those are usually narrow bands. Even the 70 centimeter band is quite narrow for this operation.
Mm-hmm. And you just answered my next question, which was, how does Spacewalker LNA fit into this to this chain of taking the information from the satellite? So what's it actually doing? Like, what is it doing? Tell me.
Yeah. Maybe I explained the main problem what I was facing and why I started this whole journey.
Go.
So here in the Tech University of Budapest, there is a ham radio club which is 100 years old recently.
That's cool.
And this is why the latest satellite called MRC 100 to celebrate that nice date.
Oh, that's nice.
Yes. And even more, that's the PocketSat, which is quite a big attraction to do, because there are not really too much satellites working out there, which is a very small form factor, like a few centimeters by a few centimeters. So you have really tight energy budget up there to gather the sunshine from your solar source.
Yes.
And it was so fascinating project. I also was in the early guys, ham radio guys, who wanted to receive this satellite and to decode some packets of it.
Yeah.
And when you're living in a metropolis surrounded by like strong DVB-T transmitters, like TETRA and LTA base stations. What happens that you have this whole spectrum, like from 100 megahertz to gigahertz, and it's all filled up with this really strong electrosmog garbage. And if you don't have a proper filtering on your LNA, it will absorb all this electromagnetic world out there. And that's not good for your LNA, because it can go into the saturation, into the nonlinear operational modes. And the most painful is you maybe even don't see what happens, because you're just observing the small 2 megahertz chunk of the spectrum with this with this RTL SDR guy. And maybe the problem is like 500 megahertz away, and it's really slow and painful to investigate it. And that was where I started to, okay, let's see what can I do. I just ordered a few SAW filters, like in a SMA evaluation board style, which is very similar to this.
Let me put you on full screen so we can have a look.
So this is a Chinese LNA, what I first started to experiment with. Not sure if you can.
Yeah, we can see that.
See.
Oh yeah, nice. One good trick is to put your hand behind it so it's not focusing on your face. There we go.
Okay, maybe. So it's if you go to, I don't know, Chinese websites and you're looking for LNA, that will be most of it. And what is funny about it, that it's like 9 out of 10 is fake. So it's not working.
Fake in what way? Like one of the
fake. I think I made a little investigation because it was blowing my mind, and I think there is a wrong IC soldered down. So maybe that was out of the quality control somehow.
I see. So like one of the components is not up to scratch on the board.
Yeah, and I don't stop there. So what I have seen that it's the current consumption was something like 4 times more like the normal. So it's obviously not working, and even the RF parameters. So I ordered some ICs again from this Chinese marketplace. That's 2 times you cannot make the same mistake, and it was like 10 out of 10 IC was bad.
Oh no!
So
you decided to make your own.
I decided to stop that and make my own. And the SAW filter is also tricky because there are not really out there for arbitrary frequency. You have to look for a evaluation board for it. So a tiny PCB where you can put the SAW filter, solder it, and it has a two SMA connector. So it's like a Lego game. So you have your LNA, you're just putting there your SAW filter, you put it out in the roof, then maybe I have a second SAW filter in the front of the LNA because it's already blinded if it's not filtered. So you have now a Lego element of 3 stuff which you have to juggle around. And still I realized that even that is not really perfect, because it's not filtered in a way like a normal RF PCB would be filtered. And it in this way you can make a possibility, or you can choose to create shielded enclosure, for example, or get somehow. But it's still, it's just you hacking something non-stop. And it's not a real solution, I think. So I just spent some time on it, and designed this LNA with a proper shielding, proper layout, proper SAW filters.
Can you show us? Have you got one prototype there? Have you got one of the boards?
Not at here, unfortunately.
Okay, we can put
I
it up
have
here so you can have a
lot
little
of at the office, but
can you tell me? Could you talk me through a little bit? What is on your board? What are all these? So here we have, and is this like coax? Is that what the cable that's going in?
It's SMA connector.
Oh, it's SMA. Okay, right. And it's like can you use? Is this the only kind of connector you can use for this type of data transmission?
No, there are like, I don't know, 20 types of RF connectors out there. But SMA is one of the most practical and most widely used. So
I can see here you've got, is that USB-C as well? And then what are the other components on the board?
The USB, just a word about it, it's just an alternative connection for powering, because it's not a really nice way to, entering noise into the system via the digital USB line. But I wanted to have a last safety option for those who cannot use the bias T option, because normally this guy is bias powered. If you check out the second SMA, there is RF plus DC connection on the out marked SMA. So what happened is that the SDR can feed 5 volts on its output on the cable back to the LNA. So it's basically powering the LNA normally. You can click it in the software, turning on the bias T, it's turning on the LNA, and you can turn it off after if you don't need it.
Interesting.
But if you don't want to use, or you cannot use it, then you can fall back to the USB, which also works.
Yeah.
But it can introduce a little bit noise. So it's normally disabled. You have to solder a little solder joint.
Oh, I see.
Solder jumper there.
Oh, I can see. Yeah. And I've got a related question here from Francisco about the thing. He said he'd like to know if you have an estimated price yet, and also he's curious about the device sensitivity. I'm guessing you're still getting all of those numbers together, but have you got any information that you can share with us about that?
Yeah, sure. The price range is a little bit surprising now in the market because everything exploded in the recent years,
It did.
and we wanted to keep it manufactured in the Europe, not moving it the manufacturing to the China.
Are you going with Eisler or who's doing your?
I
Have you got
will.
your own house?
I'm not sure who we doing the PCB. The contract manufacturer will be probably Hungarian.
Okay, cool, nice. Anyway,
So they usually, they ordering the PCB where they usually order.
yeah, interesting.
Maybe the PCB only it will be Chinese, but the assembly and all the process will be kept here in Europe.
Yeah, well, and that also helps when you're importing it into the US, doesn't it? Because otherwise you have to pay that 25% tariff, which we like to avoid if possible.
So the price range for finally back to the question, it's
Yes.
somewhere in the range of $70 or $80 range. I think that sounds reasonable.
And anything around the sensitivity?
I cannot. How can I say? I cannot answer this because sensitivity is based on this software-defined radio.
Okay.
So what LNA can tell you is the gain of the LNA and the noise figure of the LNA. So the gain is enormous. It's like something like 2 times 25 dB. So it's 50 dB gain. The noise figure of the EC, the LNA EC itself is really low. It's like 0.2 dB or something, but it's the IC itself, so that will be higher for sure, because we have a SAW filter in the input at the input port right away, which will be increase the noise of the whole system. But that's something someone have to do if you don't want to let in all the interferences of the city environment.
Very cool. And do you know, when is this? Because this pre-launch only quite recently went live, I believe. So have you got any estimation for when you might actually be going live with the campaign?
It's a good question. Hopefully very soon.
Thank you. Francisco says thank you. It's quite impressive.
Thank you.
I also wanted to highlight Leon's comment from earlier saying, Salman, check out the Libre Space Foundation presentations from FOSDEM 2024. That's already happened, I guess, of course. It's already halfway through March. How's that happening? And they were sharing their experience with launch services. So yeah, it sounds like a good talk to check out if you're interested in learning more about launch services, which we were talking about earlier on in the stream. Okay, cool. So is there any, what can we talk through a few of the other features that, I mean, I know that you also have some things to share with us on your computer. So I don't know if you wanted to take a look at that yet, or is there anything else you'd like to highlight about the board itself before we?
About the board, if you take a look at it, it has 3 shielding cages, which is probably most spectacular. That is 3 boxes. It's because
and that's the ICs underneath that, right?
Yes, the first one and the second one has the SAW filter LNA and SAW filter LNA, and the last one is a SAW filter in itself. So that's the third filtering. And not just the shielding cages doing the filtering, but it's also a proper multi-layer PCB design. That was meaning it's more expensive to prototyping it.
Of course.
Because it's not just a 2-layer. But on the other hand, you can use the natural shielding effect of the multi-layer structure. So everything hidden behind the internal layers.
Very cool.
And also that pigtail stuff.
Oh yeah, I was going to ask about that. Yeah, tell me about this pigtail.
Yeah, it's quite exotic looking. It's for the ESD protection basically. So the if you have a static discharge out there, and you will have during the storms, you're not necessarily need to have a lightning struck through your antenna.
We don't want that.
If it's enough if you have to be close to a storm.
Yeah.
and the voltage will be enormous between the points up in the air. And usually there are really tiny protection like ESD diodes and such things out there in the PCBs, but I wanted to have something more, which looks like probably a step more
Yeah.
for totally DC grounding the input. So what this coax is doing is this the other end is shorted, DC shorted.
Oh, yeah. Okay.
But in RF, it's not showing any change because it has a tuned length measured on a vector network analyzer.
Interesting.
So every incoming voltage will be shorted to the ground on the antenna. Still is not a not a industrial protection against lightning struck. that's something like in a hundreds and thousands of dollar range probably. But we'll be prolonging your LNA for sure. One of my LNA was living something like maybe 4 or 7 months up there in the roof.
Wow.
Without production. So
It's still going?
sorry?
It's still going?
No, it's died.
After 7 months. The early one.
Yeah. I had to replace the LNA IC in that. That was a different design.
Yeah.
So it's easier because those places are usually hard to go up there. If you have a tower, you have to climb up. If you have a roof, it's hard to reach, or you have remote setup, and you have to like drive your car in 2 days to get there or something like that.
Oh my word! Yeah.
You want something which is last a little bit longer.
Definitely. Got another comment here from Leon saying, I'm assuming it's, as far as I know, I think that's a typo, Libre Space Foundation launched their satellites with Firefly Aerospace's Alpha rocket. Interesting. Very cool.
Yeah, basically there are new launch companies like every month. It's a little bit similar to these CubeSat satellite companies for data transmission. There are tons of new solutions out there. So yeah, it's a competitive and really progressing market in our point.
Very cool. All right, do you want to show us the thing that you want to show us about? Unless you have anything else to say about your board for now.
Yes, I think that's about the board.
Yeah. Send if you share your screen, I can add it in. Let's remove that. Lovely thing. Here we go. Oh, yep. Here we go. How's that? Let's full screen it. There we go.
What we see here is a long-term recording of what the Spacewalker is seeing. So that was on a 5-element fixed Yogi antenna in 24 hours, and those little tiny guys there are one CubeSat.
No way.
You can see this S band because bent in S style because of the Doppler.
Oh, that's interesting.
It's the middle of the point where it's strongest. It's just ahead of your head, above your head, so it's quite stable.
I see.
It's something like that when you hear the train, it's incoming and it's Here we have another guy here.
So these little lines and these little curves everywhere. So these are all signals that are being picked up from above, and the little S-shaped thing is just the Doppler thing, as we just said.
Yes. Yeah. And it's quite beautiful, I think.
Yeah, I think so too.
There are the stronger ones here.
Yeah. Because there's some that are much stronger than others. And why is that?
Maybe that was in a better position to my station as well. maybe there are also different power levels on the satellites, because the bigger one have more joules usually, due to the bigger solar cells. Some satellites are dying and they are just almost don't have any. So it can be like, I don't know,
Dying in
5 or
like
6
how?
kilometers.
How do you know when you say satellite is dying? What is it that's dying? Is it the power is no longer functioning correctly? Is it falling out of orbit? Like what's going on?
Some even don't start work after lunch. It happens many times with the CubeSats, unfortunately.
Oh.
And if they work, then you still have sensitive parts up there, which are the lithium-ion battery, for example, and your electricity or electronics, which are exposed to the cosmic radiation. And you don't really have the possibility to shield your satellite, because these are not big industrial satellites, but small stuff. And also your solar cell is eaten up by the active oxygen layer of the Earth, if I'm right. So slowly your solar cells are dying out if it doesn't have any protection layer.
Interesting. Well, RIP satellites, but those are the dying satellites are weaker, and the ones that are bigger and stronger. I mean, that makes sense. And what's this? Yeah, I was going to say, what's this line? What's going on here?
What we see here is one of my 50-ohm terminated measurements. So there was nothing on the Spacewalker LNA input, just a 50-ohm termination. And this is what other noise it's picking up from the surroundings, which is really weak. So we are happy with it. So that's the band of interest that really glow, greenish, yellowish band here. And there will be a more spectrum. This is the spectrum plot this is the spectrum plot corresponding to this waterfall. So here you can see on this 3.3 megahertz ish way that was the most.
What are the two axes here on the
X is the frequency.
Sorry, I missed that. What did you say? X is what?
The X axis is the frequency, the Y is the dB.
Okay, yeah, thank you.
And this is basically just a self noise measurement, because it was terminated with 50 ohm. But this is the first prototype here.
Oh, wow.
Oh yeah, that will be the most interesting. That's a real antenna measurement, and this is a different type of LNA was used, and the SAW filter. What I was mentioning to you, that I was experimenting on how can I solve this situation. And this is run for 35 hours, and the frequency is going up to like 1 gigahertz. This is the higher on the right, and we have 400 megahertz on the lower. And that was a different type of LNA and filtering. And here is the Spacewalker with. So we can play a little bit to have some sense about what is the difference. That was the first measurement chart. What I have seen is usually engineers saying that, okay, something wrong with my measurement. I'm not believing it. You cannot filter out a 2 kilowatt DVB-T beast tower, but it looks like you can. So here is what I wanted to have only. This is where the SAW filters want to let in the frequencies or the content of that band.
Interesting.
And the rest of it is like, it's dead silence.
And the again, the axis. This is a time axis down the side, right?
That's a waterfall style of diagram, and it's aggregated for 35 hours. So for this, it's really time-consuming measurements and really painful to do. and it's really not obvious to make this setup for the newbies. But the tools itself are open source, and you can download it. It's like the RTL Power, whatever it's called. Yeah, I can share it later on.
Yeah, if you can share it, we'll put it in the show notes for later, for people who are watching this afterwards.
Yeah, it's the same with the same page. The right side.
Oh wow, that's really quite obvious.
Yeah,
the difference there. Wow.
Yeah, what you see here is these are the DVB-T channels, so the TV channels, and which is
really interesting.
Yeah,
oh,
and these are the LTA and GSM. And which is really interesting. You even can see where was the the night time, because there are in the the phone usage is dropping a little bit. It's darker.
It's true. You can see it. That's fascinating. Really interesting.
Maybe if we can go back here, I can zoom in a little bit.
Yeah.
I have a problem with this Google Photo because it's really mad on me, because I'm generating like 150 megabytes images.
You're really putting it through its paces.
Yes. And this is a vector network analyzer measurements. This is a small analyzer, the nano VNA. This is the actual photo of the prototype.
Nice.
This is used on our SatNox setup. This is the simple Yagi antenna what I was referring to. So
yes,
in a fixed setup you can use this really easily, and it's cheap, and you don't have you don't need a rotator. Of course, you will miss out some of the satellites which are not front of your
like straight over. Yeah,
and yeah,
very cool. Nice. And this was your one.
Yes, that's actually it's our setup. It's our setup, yeah. And this actually how it looks like now. So this is the latest version is installed, and it's still working. And here is the same measurement, but on a big spectrum, big vector network analyzer, Roder Schwarz.
Interesting.
But it was using like 40 dB attenuation on the output. So these measurements are not calibrated, because you have to add like 40 dB. So what you can see here, that it says something almost like 50 dB, or 40 dB gain, somewhere 40 dB gain. But the gain in itself is not really important. The noise figure is better.
Very cool.
Here, actually, here is the setup.
So these are some of your own observations.
Yeah, this is the setup what we have put together in order to test the LNA. We had another 2 beta testers. One was still running in Hungary, thanks to András Pál, who is working on the this quite sophisticated receiver setup with a rotator and big Yagi antennas. And another one is in the Netherlands. And thanks for the help of these beta tester guys.
For real, yeah.
Jan, another one who is testing it. So this is how you can observe your reception in SatNox. Here these green lines are the actual packet what was coming in. You can check the damage-related data, for example.
Oh, I see.
For example, here's a call sign. That's back to your question.
What call sign? Who belongs to this call sign? Is this the call sign of the device, or is this your call sign?
This is the satellite call sign.
Oh, I see.
So
I see. Yeah.
Is that actually this Tigrisat? And we can
Hello.
if we can, there is the
Oh, that's
That's
great.
that's the cosine, actually cosine of the satellite.
Of the satellite itself, and this satellite in this photograph is actually in space.
Yes,
Oh,
yes.
that's really cool. So they took a photograph of it before it went up.
Yes, that's
I like it. That's cool.
yeah, and here's the data what you can harvest here. Sometimes it's just I am alive. Sometimes it's sending down telemetry. You even can reach the audio file as well. So it's quite sophisticated stuff. Here you can see the modulation. So it's a 9.6K FSK modulation, exact frequency, and here is a polar plot where it was above your horizon.
Oh, I see. Nice. Yeah.
This is a quite new satellite, the Sonate 2. It's also received by our setup. Here you can see that it's so new that it's even not most likely what happens that it doesn't have a precise Kepler elemental database yet.
Okay.
Because it's hard to radar, making the radar Doppler correction of these tiny satellites. It needs a few days or even a week for NORAD to do this.
Interesting.
And this is because this line is not a straight line, but it's wobbling over. But at least you can see some data is coming through.
Yep, let's take a look.
Yeah, it's even can decode it. It's
and what is so under the headings CTL and PID? What are those? What does that mean? So there's the into the data. So you've got source call sign, destination call sign, source SSID, destination SSID, and then you've got the two CTL and PID with the 3 and the 240. What does that mean? Do you know what that is?
Good question. No, I don't know it.
Well, we can Google it together later. Or DuckDuckGo it, let's say.
And sometimes Satnox is doing the decoder module for each satellite, but it takes some time. Usually the universities and the who is launching the satellite itself, they have some kind of decoder telemetry program.
Very cool.
That was with the MRC 100 as well.
The polar plot on the left-hand side, which you mentioned earlier, I just wanted to make sure that I'm reading that correctly. So at the top, where the green dot is that where we start being able to perceive, and then the red is where we lose?
Yeah,
and then that curve in between, is that the route that it actually takes?
Yes. If the best for you if it's running above your head, because this is where you have the best view of the satellite and it's closest to you. And it's the most the worst case scenario if it's going on the outer ring of this radar, because that means that the elevation is really low, like a few degrees, and it's most likely the cheap fixed Yagi antenna will not receive it. You will need to have these sophisticated tracking antennas.
Very cool.
But I can show you that as well. Basically,
while I do that, I'm going to just while you bring that up, I'll want to say hi to Alvaro from Costa Rica. Hi, thank you for joining us. Says that it seems like nice hardware for tiny GS. That's one thing. But also, Leon has asked you a question, asking about your opinion on the current state of open source hardware PocketQube satellites. So if you want to speak about tiny GS or PocketQube satellites, there's people who are curious about your opinions on either of those. Or we can take a look at this. We can put those on a burner for now, back burner for now, and come back to them after you've shown us what you've got up on your screen.
Not sure about that. And I wanted.
What are you showing us here?
What I'm showing here is this is one of the most sophisticated receiver setups. So
I see.
This here you can see like 4 Yagi antennas and connected in a chain for a higher gain, and also with the tracking. Actually, these are using the Spacewalker LNA as well. So these are one of our helping in the beta testing for us in Hungary. But this building such setup by yourself at home is quite challenging. You need a lot of space for it around, and it's
pretty giant. Pretty giant.
Expensive, yeah.
Well, we've been speaking for nearly an hour, and I didn't want to let you go without asking you about how people can keep up to date with you in general. Do you have like how do people follow? People follow you on Satnogs? Are you active on Mastodon? Like, how do people get in touch with you and follow your work, just as you? But also, how do people keep up to date with what Decent Labs is up to? Like, how do you communicate with people? And do you have any asks for people? Do you need more followers on Mastodon? Do you need beta testers? Do you need people to look at the observations? Like, now is the time to tell people where to find you, and also ask people for things if you want things.
Yeah, what I'm up is you can reach me on Twitter, for example, and GitHub.
What's your Twitter handle?
RF Sparkling.
RF Sparkling?
RF Sparkling, yes.
Like sparkling water?
Yes.
Like this. I put it here in the comments. RF Sparkling. That's a great. I should have tagged you on Twitter earlier. I'll tag you later.
Okay.
Cool. All right. So people can find you're on Twitter there, and is that the only one? No other. You're not a Mastodoner, which actually that surprises me. Normally, when I come across somebody with a call sign, if they're on any social media platform anymore, like all my Euro hacker friends are on Mastodon these days. So
yeah, probably it's because I have 3 kids. I frozen in the time when the first born 7 years ago.
Retired from social media. I can't be dealing with it anymore, so I'm like, ugh. But I definitely empathize with that. But there's lots of Satnogs type people and space people and Euro hacker type people on Mastodon. So yeah.
I will check that out.
Yeah. I mean, whatever.
There were some questions meanwhile for these kind of.
Well, first of all was how can people keep up to date with your plans for your campaign? I guess people should just go to the this site, and there's a subscribe button up here somewhere. Here, yeah. All right, so you can click on that subscribe button, and then you should be able. Here we are. You are subscribed. How lovely. So that's how you can keep up to date with the with this campaign, and we've said that you're personally on Twitter as RF Sparkling. Okay, great. And then, so the questions we had was, well, not a question, it was more of a statement, but I wonder if you could speak to it at all. I'm not familiar with TinyGS, to be honest.
Yes, no, I am. Okay, I get it.
What is TinyGS? I've not used it.
If I'm right, they are using the LoRa modulation, right?
It's the open source global satellite network, an open network of ground stations.
I have to refresh my memory a little bit about it.
Oh, well, I'll drop the link in the chat. Yeah.
At some point, I wanted to check out this as well, because it sounds like a cool project.
Yeah. I agree. It does sound cool. And then the other question was about PocketQube satellites. And I'm not sure what Leon means by 1P there. So I don't know if you could enlighten us. So PocketQube is different to a CubeSat, but
PocketQube is smaller, so it's like 7 by 7 by 7 centimeters.
Yeah.
Or 5, insanely small. What about the open source? I'm not sure.
Have you been using them at all? Because are they newer than? Because I've seen lots of CubeSats, but I've not seen any PocketQubes coming through.
Yeah, it's because what I mentioned to you. I'm not sure if I can send a chat here somewhere to you.
Yeah, you can. Yeah. There's There's
That was.
Oh no.
They
There
can,
is a private chat. Here we are. Look at that. And this is a. Let me just bring that up.
this can be shared on
Yep,
the
yep, I'll do that
MRC
now.
100 satellite. They have tons of data there, and
there we go.
PDFs,
putting that in the chat.
measurements, because it's in university or the university radio club behind it. So it's always
cool.
they try to share all the. It has an English site as well. Somehow you can switch to English on the.
There we go. Oh, switch to English right at the top. Yeah.
And why there are not so much Pocket Satellite? Because Pocket Satellite is like state of the art right now.
Yeah.
It's really difficult to make a working Pocket Satellite. It's like like the Swiss watches, like I don't know, 200 years ago.
They're the next level up from the CubeSats. Very interesting.
Yeah, it's more difficult than the CubeSat in itself. It's also difficult stuff because you don't have a big space, volumetric space, and energy budget. But if you can make it even harsh, then you can go the PocketSat. What is good in PocketSat is it's less weight and smaller, easier to go up into the space, but it's much harder to run like scientific experiments.
Yeah, that's the link for the other page. All right. Well, it has been over an hour that we've been chatting somehow. It was a very interesting conversation with you. If you stay on the line after I end the stream, I'll just get some more information from you.
Okay.
But for those of you at home, that's the end of our show. Thank you very much for joining us, and thanks for sending in your questions and your comments as well. As always, it helps us feel a lot less alone. So thank you for interacting with us while we're here on stream. We don't have a stream next week, but we do have a stream the week after, also space themed. We'll be talking to a very bright young person called Zeke, who is adapting various ground stations as well. So we'll be having a chat with him with some questions from the Orosat team as well. So Orosat is the Oregon satellite program that's run at the Portland State University. So that's in 2 weeks' time. So yeah, again, thanks to our sponsor Qorvo. Check out our Teardown proposal and make sure that you subscribe to the Spacewalker LNA campaign, which will be going live reasonably soon. Although we're not going to rush you. So thank you, everybody, and see you again soon. Bye.
Bye-bye. Thank you, guys.
Oh, yes.